Hello and welcome to this video about an introduction to trig. The learning target, real simple. What is it? What is trig? So let's get right to it. There are three details about trigonometry that we need to know. Detail number one is that it is simply just a ratio of, and then this is important piece, right triangle side lengths. That right there is trig, okay? And so when I'm saying ratio of right triangle side lengths, if you know how to answer what's the ratio of stars to circles, and you go 3 to 4 or 3 over 4, you're good to go. That's it. That's kind of what we're going to have to do here. Second thing is that it needs to be a specific ratio, and that is determined by the trig function you need to use. All right? And so we'll get to that in a second. And then finally, it all has to do with your perspective. All right? So the perspective is a big detail. All right, now let's talk about this idea of a trig function. We have three trig functions that you need to know. We have sine, not sin, all right, sine. And what we're going to do is we're going to put in a random symbol right there. I'll explain that in a minute. It's called a theta. Actually, I'll explain it right now. Yeah, so it's kind of like a variable like x, but we just like to use theta when we're talking about angles. Again, you'll see how that's an angle in a bit. That is equal to the opposite over the hypotenuse. We have cosine of theta, which is going to be equal to the adjacent over the hypotenuse. And finally, we have tangent of theta, which is equal to your opposite over your adjacent. Now, you're probably wondering, what do I mean by all of this? Well, let's draw a right triangle. There we go. Here's our angle, theta. So again, this guy's theta. And here's where we're getting this idea of like a specific ratio, okay? If we're looking through theta, so imagine there's like a little dude right here, and he's seeing things from theta's perspective. We have three legs to our triangle. You have the opposite side, you have the adjacent side, and you have the hypotenuse. Adjacent means next to, so it's the side that's next to the guy. Opposite is on the other side, so that's why we call that the opposite. And the hypotenuse is always the longest side. And then when we say something like, specific ratio right here, sine says I have to take the opposite over the adjacent. So I'm going to be using whatever this length is over that length. And then I'm going to answer it just like you would up here, saying what's the ratio of stars to circles? 3 over 4. And so that's it. Essentially, when we are just getting started with trig, it is all about coming up with fractions. That's all we're doing. We're making fractions. So let's do a couple of examples. So let's make a triangle. And let's say, we'll call this, let's put a line there. Let's put a theta there. 7, 24, and 25. All right? And I want to come up with the sine of theta. Well, here I'm looking from this perspective. Sine is opposite over hypotenuse. So my opposite side is 24. My hypotenuse is always the longest side. I forgot to put the right angle symbol there. So that's going to be 24 over 25. Oops, writing in shapes. That's why it's all pixelated. There we go. 24 over 25. And if I now want to do cosine of theta, that's going to be the adjacent over the hypotenuse. And so the adjacent side is the one that's next to the angle. So that's going to be 7 over 25. And finally, if I want to do tangent of theta, excuse me, that's going to be my opposite over my adjacent, which is equal to 24 over 7. So hopefully you kind of picked up on this. You need to know that right there. You need to know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We have an acronym to kind of help us with that, and that is SO, CA, And that stands for sine is opposite over adjacent, or hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Again, let's do another example here. We're going to mix it up, make it a bit more fun and exciting. So let's say, now instead of saying theta, I'm going to say A and I'm going to say B. I'm going to label those angles just with letters, okay? And I'm going to go with a good old 5, 12, 13 Pythagorean triple. Now, the trick that we're doing only works in this regard for right triangles. We don't have a right triangle, we can't do it. Just going to throw that out there. Now, what I'm going to do is I'm going to spice things up a little bit, and I'm going to say, hey, what's the sine of A? And then what's the cosine of B? So, actually, let's do this in different colors. That might help us a little bit more. All right, cosine of B. Well, since I got my red pen going, let's do that. B means I'm looking through this perspective. And that is supposed to be my adjacent over my hypotenuse. Well, the side that's adjacent from this perspective is 5, and the hypotenuse is 13. My sine of A, I'm looking through this perspective, I need the opposite over the hypotenuse. Well, when I'm looking at it from A, I'm still going to get 5 over 13. And so that's why the perspective really matters. Depending on what angle you're looking at, you can get very similar or very different answers. All right, and then just to kind of do another example, let's say I want the tangent of A. Well, tangent is supposed to be the opposite over the adjacent. And so from perspective A, that's 5 over 12. I go to cosine, or sorry, I go to angle B and I do the tangent there. Still the same ratio, opposite over adjacent, but what has changed is my perspective. And so that's going to give me 12 over 5. So, take some practice, takes a little bit of getting used to, but here's what we got to know. We have to know SOHCAHTOA. You know SOHCAHTOA, you're going to be able to kind of get started with it and take it from there. So, again, trig is nothing more than applying some ratios. And right now, all we're doing, writing some fractions. Eventually, we'll be able to use these fractions to do other things. But right now, just to kind of understand what trig is, it's the ratio, or let's actually go back to that screen where it says it. Right here. It is the ratio of right triangle side lengths. Good luck with your homework or practice, and let me know if you have any questions.